Greg, how did they get the picture of this so good?
This all happened 8 minutes ago, and
Right?
no. Okay, you're on a different feed. I'm on the.
We have indication that
they're carrying the actual NASA
separation
feed on
has been confirmed
PBS,
by the
so that's cool.
spacecraft.
Yeah, if you have a better feed, let me know and I'll skip to that.
It's pretty much identical, except it's direct from NASA. So I kind of feel like
That's better.
The first action we'll
yeah,
do
fire it up.
is
We'll
to fire
we'll replace it.
warm-up pulses with the entry thrusters.
All right,
These
here we
pulses
go.
ensure that the spacecraft These pulses ensure that the spacecraft gets the thrust that it wants during entry.
We need more volume. It's lower.
9 minutes from entry.
It's as loud as it goes.
Yeah, let's switch it.
Okay.
And we'll eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
Maybe it was just that dude.
Well, I turned my volume down because you. Corey Elko.
Confirmation that we got shadowed by the cruise stage as it passed through beam to the Earth.
Uh-huh.
No, you're on the right show, Corey.
Telecom indicated actually that we see the signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters.
Warming up is good.
Have begun.
Warm up the thrusters.
Fire in the sky. Literally, it kind of works.
It's spin from the cruise 2 revolutions per minute down to 0, and then we'll transfer the desired orientation.
We think so too, Sam Ronan.
It will separate the 2 ballast masses that have kept it balanced.
Yeah, that's just true.
This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
I'll bet you won't hear this on ABC. Holy fuck balls! It worked.
Yeah, I mean you're gonna hear that the whole time, whether it works or not.
And now we've spun down from 2 revolutions per minute that the vehicle had the whole way to Mars as a spin stabilized spacecraft. And then from here on out, it's going to just be a bullet and can control its orientation and attitude via rockets on the back of that batch.
Points carrier lock. Sorry, and we're the DTE from Radio Science from Green Bank reports carrier lock.
Oh my god! 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 Oh my god!
In the downlink.
It's like, can you imagine like somebody hires you and like, hey, can you build us a sky crane?
We are continuing to wait.
And your first answer is like,
about 6 minutes and 45 seconds.
We can do that.
We have confirmation from Greenback that they are receiving direct
Can confirm.
telemetry via that.
That's why people don't trust the news anymore. Not enough fuckballs.
Currently transmitting heartbeat.
Although I wouldn't put it past Dan Rather, a couple of bourbons deep on a cold winter night to.
Yeah, that's why he's not on TV anymore. he's on Twitter now, where fuckballs belong.
We're currently just over 6 minutes from entry interface.
I love that I don't even have to explain what it is we're doing, what we're streaming here.
Yeah, everyone's met us.
Okay.
Did we share this back out to the?
Yeah, it's on the Uplifters channel as well. I thought I was taking a half-hour break. It was like a 2-minute break.
Yeah, it'll be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle.
Is it a jar of peanuts with a Perseverance label on the side of it?
We're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the
Same as
temperature
here.
drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface.
She's
Perseverance
nervous. You
is
can hear her
on
voice
heartbeat.
getting.
Of course she is, dude. Like, this is like, hey, no pressure. Everyone is watching you. And also, don't crash your spaceship.
Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the Electra radio is powered on, ready to receive signals from the lander.
Okay. MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight level 1
from entry interface.
So when we go back to the moon and Mars with people, that's how we'll get signal. They'll be beaming it to another spacecraft and back to us here on Earth.
We really need it for
$5. It's a SpaceX BFR in orbit.
keep our nerves in control.
Around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance will transmit heartbeat tones, indicating everything is nominal.
It's nominal,
No
lady.
one can tell us whether something's bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land.
That's definitely a jar of peanuts with a Mars reconnaissance, or with a
Yeah,
with a Perseverance label on the side.
they open it if it lands.
Oh yeah, is that? Do you know that, or are you just making shit up now?
$5, it's right.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second.
See that person behind her.
About
If anybody
90
gets like
seconds from
too
entry
angry
interface
or
and
too upset or
standing
jacked
by
up,
for Mars reconnaissance orbiter.
they take care of it. That's what attitude control means.
Never use that joke again.
Make me.
I mean,
Well, come over here and say that.
your nerd point's just like cratered. You have a lot of them to spare, so you're probably fine.
No, not the individuals, Gail. They're
1 minute from entry interface.
you're hearing her voice, and she's sort of translating what else is going on in the room for us.
Yeah, and they can't do anything.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
Holy fuck balls, indeed.
Yep.
About
Wait,
from entry interface. 3 kilometers per second and an altitude of 150
Never mind.
kilometers from the surface of Mars.
Here we go.
Oh, jeez.
I know.
Confirmation
I'm
of
nervous.
Entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
Mach 28.4.
That's pretty fast.
Oh my God. That's
Is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
This is where the terror starts.
so that was the telemetry that was being transmitted from the Mars Reconnaissance
We have
Orbiter.
indications that
Yeah, it's feeding that
Perseverance is
animation.
now performing bank reversals in the atmosphere. These are the steps in order to control its
Bank
Oh, okay.
reversals.
pass through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has locked again.
We saw a
Here's
small
somebody whispering, yes,
uh,
yes, yes,
of
in the back.
VHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
Why didn't I start a heavy metal band called Plasma Blackout?
Or bank reversals.
Right? Missed opportunity.
That man looks like he's about to poop his pants and or throw up.
Perseverance is going about 1 kilometers per second at
That's some deacceleration.
10 kilometers from the surface of Mars. We have entered heading alignment, which means
Down to Mach
Perseverance is no
4.3 now.
longer
Look at
trying to
that.
Control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Yeah, that's only 2,500 miles an hour.
Yeah, it's no big deal. No big deal. That's fine. That's fine.
Wow.
Nervous slurping.
Down to 2.71 Mach.
Yeah.
590 meters per second. Jeez.
I love that they.
Is about 550 meters per second at an altitude of about 15 kilometers from the surface.
It's almost like they're using Kerbal and then updating the information. You know, for the animation. I approve, JPL. I approve.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to
Mach
roll
2.
over to give the radar a better look at the ground. The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 430 meters per second at an altitude of about 12 kilometers from the surface of Mars.
This is awesome.
Perseverance has now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
So, do we know if they're going to get even? I mean, this all happened 8 minutes ago, but telemetry on the rocket, like on the Sky Crane rockets.
Don't know. I don't know what the story is there.
Okay, I guess we'll find out in a minute.
Yeah. Yeah. Yeah.
Perseverance now has radar lock on the ground. Current speed is about 100 meters per second, 6.6 kilometers of the surface. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
2 miles, 12,000 feet. That's about the height airliners go over us here.
Confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have priming of the landing engine. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. That the back shell has separated.
Powered approach.
Performing the divert maneuver. Current velocity is about 75 meters per second at an altitude
That's good.
of about a kilometer off the surface of Mars.
Kieran, safety Bravo.
There was a data skip there.
Completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
That's very close.
We have started our constant velocity accordion, which means we are conducting the Sky Crane, about to conduct the Sky Crane maneuver.
So this is when
Yeah.
it separates from the.
As expected. As expected.
Sky Crane maneuver has started. We're 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance. On the surface of Mars, ready to begin seeking the sands of past life.
That's cool. Yeah, I'm here for it.
At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Autonomous Orbiter.
She's
to-
breathless. That's her in the foreground down here at the
Yeah,
bottom.
yeah.
That is crazy.
Oh my God.
Oh my god.
Oh,
Sometimes I feel like I get romantic about all the wrong things, but this is amazing.
Still getting
This is
telemetry from the lander.
Their whole careers, 10
Yep.
years of their lives to get to this day, this moment.
All stations.
And it all worked because they're all incredible.
Touchdown confirmed. We're going to wait for the images.
I,
Wow.
this is so exciting. And the team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
Great.
Pictures would be rad. Imagine it takes a picture and there's just like this green alien. That's not gonna happen, but it'd be really cool if it did.
There's been writing on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
Awesome.
We're getting pretty good at this.
Of EDL 3000. Copy activity. That is as expected.
Yeah, 4 years from now, when they land at BFR on Mars, that's gonna be like, what?
Strong signal.
What?
Strong signal.
Mm-hmm.
We we've just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It's the first image.
Nice.
Here is a look at the first image.
You
It's
said it,
not-
James.
It's not big, but it is good.
The target point on the map when you are ready.
We are ready, OL3. Go for it.
Ooh. That's their area.
Yeah, that will have been taken from altitude.
Yeah.
So I'm really anxious to see where it put the rover.
Moving in, showing you the safe zone that we've landed.
How close are they to the? Looks pretty flat. Good job.
Just put the first image from Perseverance on the surface of Mars. Now it comes from the engineering cameras known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
23 cameras on the rover, 2 on the drone. 25 cameras total on this mission.
Sigh.
It's amazing.
I'm super excited that this rover's primary mission is to look for signs of past life on Mars. It's been a byproduct of exploration before, but the primary central purpose for landing where they did at this crater is because they think it's the best percentage chance of them finding evidence of at least microbial or past microbial life on Mars. And, you know, in the shade sidewall of a crater, in standing water or in ice,
Yeah.
there could still be life on Mars.
You did.
And I can't get over the idea that this would be the first time in human history that we would have verified life anywhere else in the universe, anywhere else.
It's just, it has such amazing ramifications too, because if Mars has life, the moons of Jupiter probably do, right? And
That would mean
Lisa-
our sample size of
Yeah,
planetary bodies we've landed on with an atmosphere.
Second
2 for
image-
2.
Yeah.
Our
Right?
second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. You can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening.
Right now, 8 minutes ago.
Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing.
Well, that's always good.
Right? Nailed it.
No, this is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
I'm here for it.
I want to thank you guys for
Joining us
joining
now
us with this
is
for this
the
today.
Acting Administrator of NASA, Steve Jurasik. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and what just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions, and then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars, and then for UN exploration. We have the Mars landing instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us properties, size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because
a tweet by a robot just made me cry.
And then
Yeah, no one is shocked by that, dude.
You see it?
That will be
No.
mission.
Look at the screen.
First round trip to Mars and
Hello world. My first look at my new forever home.
Perseverance.
It's a tweet from Perseverance rover.
Stupid.
I know, right?
Here on Earth.
I like it.
And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith. And then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels.
Yes, she's like,
The Surface Operations team has now taken over. What are they doing now?
Yes. Hi, Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the landing team will be working overnight while the rover is asleep, so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be.
Corey is describing the landing to somebody on the phone right now. It's
late nights, but we're also excited, and we can't wait.
It's a whole new lifestyle.
Yes.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sophia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
Well, two things. I mean, it's the biggest and best rover we've ever sent to Mars. And it can really, do amazing things in terms of, its own scientific exploration of this habitable environment, at Jezero. But, it's also, as you've heard today, it's the first step in Mars sample return. So really, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, a lot of the effort to develop the rover was specifically designed, for that sampling and caching system. It's one of the most complex robotic systems ever made. And, having it down safely means Mars sample return continues right on course and we are moving forward.
Wonderful. Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
There's a lot of reasons. I mean, obviously, for places that are far away, like Mars, and even farther away, like Europa, right now, robotic exploration is the only way we can make these scientific discoveries and really understand these early habitable environments. In the case of Europa, maybe it's even still habitable. And, we're not ready to go there with astronauts yet, but the robots are ready to go there. And so we always, are forerunners and pathfinders of human exploration. And we start by sending, our eyes and arms there in the form of a robot. And it is just fantastic to be able to do that and to learn from each rover, learn from the science and the engineering and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries. And each one is more exciting than the last.
The future does look exciting. Now, as director of JPL, what would you like to say to those teams right now celebrating?
Oh, obviously they have earned it. Let me tell you, I mean, they have worked, for years and years on this mission. And then in the past year, of course, we had the COVID experience. And I want to thank not only the team, but also, all of JPL. A lot of folks had to pitch in here, in terms of making sure our remote telework, our IT systems were good enough to support folks working from home. All of the folks looking at PPE and our safe distancing and reconfiguring facilities to make them safe for the employees. It's just an incredible amount of work by the entire lab, and of course, especially by this team. And and in one sense, the 7 minutes of terror are very exciting. But on the other hand, the mission's just started, right? We built the mission, not to land, but actually to drive and get the samples and do other technology, demonstrations. And so, for much of the team, this part of the mission's over. But for most of the team, the mission's really just starting. And so, I think they're very excited. But everybody, I think, can take a deep breath and a sigh of relief now that we are safely down on the surface.
Yes, that collective sigh of relief. And I hear a lot of excitement and celebration behind me as well. So thanks so much for joining me, Mike.
It's my pleasure. And thanks to everyone for joining us, too.
Congrats again to the Mars 2020 Perseverance team for a successful landing. Back to you, Raquel.
Now, there will be a flight test coming up for the Ingenuity Mars helicopter. And if this technology experiment is successful, it would mark the first time we have taken a power-controlled flight on another planet.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering.
Sorry, because we watched most of the videos that they're re-showing over the past several days of shows. So I'm gonna make the call to go ahead and end the stream so we can all go watch this on our own computers or on our big TVs to see the pictures as they come in. Corey disconnected from the chat. Not sure why, but we're going to call it a day. And I'm going to go watch some more amazing footage come in, and I'm going to build stuff in Minecraft and have myself a great day. I hope you do too. Thank you so much for joining us for this and things like it. We love that that our fan base is as engaged by this kind of amazing thing as we are. Deb Marcotte, in case you don't know, is Corey's mom, and she posted here a few minutes ago. Corey at about age 11, Mom, I'm reading a great science fiction book. It starts at the beginning of time, like when men walked on the moon. Yeah, I was 5 when that happened, you little shit. Anyway, so thank you for joining us, and we'll be back on, what's today? Thursday. We'll be back tomorrow with our regular coffee show. That'll happen at 10 a.m. Eastern time. I hope to see you then. Other live streams all over the clock, all over the week, all over the month. Lots going on, and we're happy to tell you about it. And for now, that's it for a Hashtag Coffee Special Edition. Perseverance rover safely on Mars, sending back signal. The Alpha Nerds triumph once again. Sasquatch is real.